Hi, this is Zhihao again. I'm the co-founder and CEO of Genia. Over the past couple months, our team has been working really hard, and today I'm really excited to share with you that on Genia's structural AI agent, we finally support the rafter roofing system. And today, I want to show you with a live project to see how that works. All right, so if you go to genia.design, this is our website. So hopefully by this point you are familiar with our website. And if you have a registered account or if you haven't, it doesn't really matter. You can just go ahead and click the Design Now button. That should bring you back to your dashboard. So as usual, on your dashboard, you can access all of your previously created projects right here. And you can flip through different workspaces if you have multiple ones set up. Right. As before, we can just go ahead and click the top right corner to create a new project. So we're going to use the same two-story single-family house that we have seen before, but instead of using trusses for the roofing systems, we're going to use rafters. I'll go ahead and create a new project right here. All right, so for this, we're going to upload the architectural drawing in AutoCAD file format to our system. All right, so by the way, as you can see, on the right-hand side, we're going to have a few upload guidelines for you to read through. You might need to probably change or update some of your architectural drawings to comply with the guidelines. And during the upload process, we're actually going to run background checks on your uploaded DWG or Revit files in accordance to this guidelines. So there are specific things like, for example, we're requiring all of the lines for walls to be on a separate layer called A-wall, and the grid lines to be put on a layer called A-grid, things like that. All right, so we'll go ahead and hit the continue button. We're gonna say this is a sample project using rafters. And as before, we're gonna use our address in California, Los Angeles. This is where our office at, by the way. So, as I said before, this is going to be a two-story single-family house with no basement. So I entered 2 for the upper structure, 0 for basement. And once again, we're going to take a look at the building codes that's fetched based on the location that I just entered. All right, so we're going to go with site class D, exposure category C, risk category 2. All right, so based on the information that we entered, we're integrated in the backend to SE7. So here are the different environmental loading parameters that we obtained. Just same as before. So these are the seismic parameters. These are the gravity, live load, dead loads. You can always change any of these. If you do have geotech reports, these are the soil parameters that we're designing against. If you end up getting an updated number, you can change them directly in this interface. Here are the deflection limits, different kinds of materials allowed, and here we basically give you different options to design the shear walls. All right, so we'll go ahead and hit the next button. So as before, in step 2 and 3, we are going to remodel the architecture, the uploaded file into our system, right? So step 2 is to make sure that we understand, each area denoting to each part of the floor. So, as you can see, here, this area denotes to floor 1 or level 1. This area is level 2, and this is a top roof area. That all looks good. I'll go ahead and hit the continue button. So in step 3, this is where our AI does the job. Within each floor box, we're going to be looking within each of the floor box and search for the critical architectural elements that are relevant to structural design. So things like walls, windows, doors, openings, these stairs, these are critical architectural. These are considered as critical architectural elements. And this bottom floor looks fine. We're going to inspect through each one of them. As before, on the bottom left corner, this is what we call an anchoring point. So when we stack up all of these floors and roofs together, this is a common point that we're going to be using. So typically, this anchor point is the one of the intersection points of these grid lines, right? And if you want to inspect the model in 3D, we do give you that option. So this is, you can basically prompt to all of the floors, and right here you can insert a section view to inspect the model closely. All right. That all looks fine. And one more thing about the roof that I do want to mention. So here so in the truss example, we're not asking you to submit the pitches of the roof, but for rafter systems, it's critical that we understand the slopes of the roof. So here you can not only define each piece of the roof, but rather tell us exactly the direction and the slope. The rise over run. So it's typically 12.4 inches by over 12 inches, rise over run, right? So this is the definition here. If you want to change any of that, you can just directly click on each piece of the roof, and here you will be able to adjust the direction, the rise and run. All right. So this all looks good. I'll go ahead and hit the continue button. So as before, we're going to need some of your help reviewing and adjusting the roofing plan before moving on to the superstructures, right? So the rafters are pre-populated. We might need some of your help looking for the bracing and the purling systems. So for example, these bracings are actually a little bit erroneous. We probably want to delete these bracings. What we end up missing was essentially we need to add 2 purlins, right? So for example, one way of doing that is you can add a purlin right here and add a purlin right here. And by the way, if you want to insert a linear item that are very straight, perpendicular to the that are straight or that are off a straight line, you can press the shift button. That will basically allow you to insert a line item that's either horizontal or linear. That's the way to ensure perfect alignment, right? So this all looks good. What we need to do on top of that is to add the bracing systems that are supporting each piece of the purlin. So in order to do that, we're gonna shift over to the 3D view, right? So this is what we call the editing mode. So if you go ahead and create a section view, that's recommended. So it's really recommend that you create a section view before you add the bracings. So you can basically look at, I probably want to add a bracing between this point where the purlin intersects with this piece of a rafter and on top of this piece of a wall. So I'll go ahead and click the bracing button. We have snapping features, so automatically you will be able to place the starting point of a bracing at the intersection. So for bracing, we are actually requiring certain the bracing elements to be added in certain directions, right? So it's a linear item. You need to define the highest points and then the lowest points in sequence, right? So I'll put the highest points here, and once you add the points, then we're gonna place the lowest points right here. We're gonna have a few suggestions where we think could be the possible candidates where you want to place the ending point of a bracing, and we understand sometimes the intersections where this bracing with the horizontal plane can be critical. So as you move along, we will be able to you'll be able to see that angle as a reference, right? So we're going to add that bracing right here. And by the way, if you want to change the section view, you can hold the control option on your keyboard to adjust this the section view. So we're going to move along. So we probably need a separate bracing for this, for this piece of rafter 2 of this section. So I'll go ahead and do the same, add a bracing right here, right? So just as simple as that. All right, I guess for simplicity, we're gonna just put 2 bracing along the purlin. All right, I'll want to put a bracing right here between this intersection and on this wall, right? So in order to do that, I'll create a bracing and then add it right here. All right. And lastly, for simplicity, I'm going to add one more bracing to support this purlin. This is a very long purlin, so in reality, you probably want to add multiple bracing to support the purlin. But I guess for simplicity of this demo, I'll just go ahead and add one last one to complete the operations, right? So it's just as easy as that. So right now, these two purlins are being supported by these two these bracings at each end, right? So that all looks good. I can go ahead and flip back to the 2D model. Now that you can see, here these are the bracings supporting this purlin. These are the bracings supporting this purlin. This is probably one of the simplified way of doing this, but this all looks fine. Then you can also inspect this in 3D once again. So normally this will be what we call the reveal mode. But if you click on one of the rafter systems, this will get you back to the editing mode. All right, so this all looks fine, and then I'll go ahead and hit the continue button. Once I hit the next button, what's going to happen is that we're going to first model the rafter systems based on your suggested layouts. We're going to calculate the internal forces, calculate the demand capacity ratios for each piece of the rafters, and based on the loads that are being passed on to the superstructures down below, we're going to use that load as a reference, and then that will help us guide the generation of the bottom two floors. All right, so this process, will take slightly longer, longer than the trusses systems. We're going to report back once the generation is complete. All right, so now the generation has been complete. So after about 23 minutes, you're now able to see multiple design options being generated. So as before, you can click on the little arrow right next to option 1 that will bring up the sort of the drop-down menu where you can click on different check out different options. And if you want to have a comparison view, you can click on the compare option button that will bring you these pop-up page where you can see the cost differences, DCR, constructability summaries. Right. So as before, you'll be able to inspect the model in 3D, right? So since we're able to understand the roof structures, you can now see this entire structure, in 3D with the pivots and the pitches of the roofs, right? So as before, you can create a section view, look into more details. You can rotate the section view to whatever angle that makes sense, and you can drag and drop and inspect the model as you wish. But for most of the engineers, I think it will be more intuitive if you look at the 2D view. So right here on the left hand side, you can flip through different floors. So as you can see, here are the different design results for the top roof. We're going to follow the rafter layout that you just did, and down below you should be able to see different shear walls, results, etc., etc. So as you can see, if I click on this piece of shear wall, I'll be able to look into the design details. Right, so it will tell you, how much forces this shear pier is exerting, how big that force is, etc., etc. And for this piece of shear wall, we're using segmented approach. But if you want to change it to perforated in case there's an opening or FTAO, then you can change this through this calculation methods, button. As before, you'll be able to change the different materials and trigger another rerun. If you click on this purlin, for example, it's going to bring you a purlin calculation result, right? So it will tell you the moment shear deflections, and the results diagrams. Same for rafters, right? So these are the different kinds of spacing. You can change these spacings if you like. You can flip the directions and trigger another rerun. And just as before, you can click the export button on the top right corner. That will allow you to download a zip file. So in this zip package, you're going to see two things. One is the structural drawing once again in AutoCAD format. All right, so this is a rafter relevant AutoCAD drawings, and here are the relevant details. So, and on top of that, we also produced the calculation report. So we're gonna open it up. So here are the 400 pages calculation report. It will walk you through the detailed design basis, different loads design across each of the floor, vertical and lateral loads resistance systems. And we're going to give you, different critical members. So here you'll be able to see different calculation results for rafters, purlins, bracing, joists. Every single member that you design in the system will be able to show in the calculation report. All right. So with that, this concludes the demonstration using Genia structural AI agent designing a single-family house with rafter systems. We're excited to launch this update, and we look forward to your comments and feedbacks down below, and look forward to seeing you in the other video. Thank you very much for your interest in Genia. Bye-bye. And on top of